All right, so we are going to take a look at a couple of sections. First, we're going to look at section 2.6, which is titled Special Functions. And you can see over on the left side of the screen, we're going to first take a look at question number 1. This is what we call, it's not named there, I guess it is right below that, but notice piecewise here. Number 1 is a piecewise function. Number 2 is a piecewise function, 3 and 4 are piecewise functions. But what you see there is we have g of x equals bracket, and then there's 3 different functions. So it's saying that g of x equals -3 for part of the time. G of x equals x for part of the time. And g of x equals the negative x plus 6 for part of the time. We don't have full graphs. Our final product is going to look something like number 3 or number 4. Those are some piecewise functions where you have different portions of lines. These happen to be lines here. And so we're going to graph these 3 portions on the same graph, but pay attention to the domain, the x values, those restrictions that are placed on each one of the functions. So if we come over to the graph over here, the first domain value x is less than or equal to -4. So if I came to -4, I'm going to, for a moment, just going to kind of break it apart like this. I won't typically do that, but I might do it for right now. And so this graph, the -3, is happening to the left of there. And then we see between -4 and +2. So +2 would be like right here. And I'm just making these open intervals, mostly because I don't want to draw a big heavy line there. But that middle graph is happening in between there. And then the third one is when x is greater than or equal to, so to the right of the 2. So we really kind of broken into 3 chunks. So let's focus on the first one, the -3. So we're thinking about g of x equals -3. Now that doesn't have an x in it, which means it has no slope. It is a horizontal line with a y-intercept of -3. So if we were going to do the whole graph, I would go to y to -3 and put a point there, and then it's going to be a horizontal line through there. And I'm just doing dashed here for a second. But we would have that line. But we don't want that line for all of eternity. We don't want to keep going forever left, right. It tells us only when the x value is less than or equal to the -4. So at the -4, there is a closed circle because it could be equal to, and then I only want less when x is less than, I only want left than there. So to the left, I'll go ahead and make that a little more bold. But then the rest of that line, I'll try to do a little bit of erasing without erasing all of my graph. I don't want any of that. I only wanted a closed circle and everything to the left. And that's the first part of that graph. The second part, g of x equals x. Well, that would be have a slope of 1 with no y-intercept. It crosses the y-axis, has a y-intercept of 0 and a slope of 1. So we rise 1, run 1, rise 1, run 1, etc. Down 1, back 1, down 1, back 1, down 1. We can go as far as we want to. But we have that line, but we know at -4, it's not equal to there. Oops. It's an open interval. That's where it would have hit if I followed my slope, would have been there. At 2, that's also an open interval. So if I followed my slope, that brings me all the way to there. So that's another open interval. But I do want everything in between there. So I'm going to connect those with a segment. And then lastly, I went to the right of the 2, and I have a different function, y equals -x plus 6. That's a y-intercept of a positive 6, and a slope of -1. Now 1, 2, 3, 4, 5. So I would have gone up here to 6, and then done my slope, which is down 1 over 1, down 1 over 1, and then you could continue that down 1 over 1, down 1 over 1, etc. I'll go a little bit farther maybe. Just we'll finish it off. Okay, but I don't want that entire graph. I only want to start it at the 2. It was a closed interval, so I'm going to do a solid dot there, and then I just shade or graph the part that's to the right. And it's like array, it's gonna go on forever to the right, but it doesn't go any further to the left. So I might come back and erase those first couple points I made. And so there's my piecewise function. That's what it looks like. That's my final answer. Now, I don't necessarily want to draw full lines every time and then go back and erase. What I might have done, let me erase some of this over on the left and show you how I might have approached this, especially this middle piece, where I have two intervals, -4 and 2. I would probably recommend finding both of those order pairs. Plug them in. So here's the rule, x. So when I plug in -4, maybe I should put it on the line below here so I don't get confused with the first graph. But when I plugged in -4, I would get an answer of, well, just -4. Because you didn't do it, there's no multiplier, nothing to add or subtract it. When you plug in 2, you're going to get an output of 2. So I know those are my endpoints. So then I could come over to the graph, -4, -4, put a point, knowing that it was an open interval. And then 2, 2, go to 2, 2, open interval. And then you could just connect the dots. You wouldn't even have to know your slope. Similarly, what about the rest of it, the right of it? Well, the right piece, I'll go to the right piece there. 2 is the only domain value given. So let's plug 2 in and see what we get. So plug it in, -2 plus 6. -2 plus 6 is 4. So when I plug it, I got it now, 4. That is a closed interval. So if I go to 2, 4, closed interval right there, that's where I would start. And now, so instead of starting with a y-intercept of 6, I don't really care about the 6. I wanted to start with 2, 4, and then my slope is -1. So -1/1, I go down 1, right 1. Down 1, right 1. And then you can continue to do that, and you get that graph. Now, what about the left part? The main value they gave is -4, so we plug -4 in. There's nothing, there's no x there, so we just get an output of -3. So, and that's a closed interval. So we go to -4, -3, closed interval, can put our dot, and then that one didn't have a slope, so we need to recognize it as a horizontal line. We have to make sure we go the right direction. We're to the left of -4. It's kind of like a number line. You just go straight left. Slope of 0, no rise, it only runs. So let's take a look. So that was number 1. Let's take a look at number 2, another piecewise function. Let's switch colors here. We'll go ahead and switch colors accordingly over there. Okay. So 3 functions, 8, 2x, -4 minus x. The first one, 8, we only look at where x is at -1. So closed interval, plug that in for an x value, plug it in here, there's nowhere to plug it in, and just get 8 for an answer. So -1, 8 is a closed interval. 2, 3, 4, 5, 6, 7, 8. And then I want to go to the left because it's saying less than. This is a slope of 0, that's a horizontal line, so I have to go straight left. And it keeps on going to the left forever, so I put an arrow on the left part. There's the first portion of my function. The second one has x or domain values of -1 and 4, so let's plug both of those in. I plug -1 in, 2 times -1 is -2. And then I'll also plug in 4. 2 times 4 is 8. So those will be the 2 endpoints of this middle section. It's really a segment, not an array. So -1, -2 was an open interval. And then 4, 8. 2, 3, 4, also an open interval. 2, 3, 4, 5, 6, 7, 8. And I just want to connect those two. So take my ruler here. Do the best that I can to line those up. Okay. And then lastly, the third part. I have a domain diagonal and they give me a 4, so plug 4 in to that function. -4 minus 4, that's a -8. And this will be a closed interval. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. We set a closed interval there. And then I can start there and do my slope, and I am moving to the right. And that's really kind of what I would typically go -x minus 4. So -4 would have been -1 is my slope. So -1 down 1 to the right. So from here, down 1, 1 to the right. Down 1 to the right. You could continue to do that. And then you're going to connect the dots starting the endpoint and then moving to the right. And so there's what that second one looks like. It's called a piecewise function. They are functions because they do pass the vertical line test. If you consider number 1, vertical line, vertical line, vertical line. Okay, this dashed line, notice it hits an open interval and then a closed interval and then an open interval. So it's not hitting both of those. It only hits one spot, so it does pass the vertical line test there. Continue traveling, there's no overlap until we get here. On there, there's a closed circle, but then an open, so it's not hitting both of those at the same time. Then you move to the right and you're fine. So this is actually a function. Same thing happening on number 2. There's only one function happening until you get to -1, and then there's a closed interval, but then there's an open interval, so it only hits one of those. And when you move to the right, you're only on this second middle piece till you get to 4, but then you have an open interval and a closed interval, so it doesn't hit both of those. It only hits down here, and then you move to the right and it follows that one. So that also is a function. So now if we look over here on the left, they give us a couple of pictures, and they want us to write the piecewise function. They do tell us right here g of x, not f of x, not h of x. It's not really that important. But there are 3 pieces. Make the bracket here. Leave room for 3 parts. The left one. Well, the left one is a horizontal line. Horizontal lines don't have a slope, they have a slope of 0. This one looks like it goes through 6. So it's y equals 6, or g of x equals 6. If, and then I'll tell what the domain restriction is. We started here, it looks like at -5, open interval, or closed interval rather, and then it was to the left. So we were saying that x was less than or equal to the -5. That's the domain portion where I use that line. Then we move to the second section. Let's think about what this equation would be as a line. Maybe think about the slope. So from here, notice each of these lines on the graph are going by 2's, both on x and y. So we're going down 1, 2, 3, running 1, 2, 3. So our slope, we went down 3, we ran 3. In total, that's -1. So we're going to have a -x. Then we have to figure out either what our y-intercept is. You can do that by continuing the graph until you get there. So down 1 over 1, down 1 over 1. If you kept going, it looks like it would cross at 4. So I'm going to have to +4, probably. The alternative to that, and it doesn't always work out nicely, because what if it's a decimal? Let me show you maybe a better way to find out for sure what that y-intercept is. One that will work all the time. Think about our point slope form. Y minus y1 equals m times x minus x1. We found our slope to be -1. And then pick one of those ordered pairs. Maybe I'll use this one right here, which is a -2, 6. So plug -2 in for the x, plug 6 in for the y. That becomes plus, distribute your -1, I get -x minus 2. Go ahead and add the 6 to both sides. And y is equal to -x plus 4. And so that -x plus 4, that's what we put over here in the function, -x plus 4. And then the domain restriction, let me make some room over here. So it started, we're talking horizontally. So think from there to there. So it starts here at -5 and it went to 2. So both open intervals. If -2 is less than x is less than, oh, sorry, what did start with -2? My bad. Started with the -5. -5 is less than x is less than -2. Those were the x values where it started and stopped between -5 and -2. And then we switch over to the third part of the graph. Let's think about what this says as an equation. So slope. Remember, we're going up by, there's 1. Looks like I can go up 1. Oops. So up 1 and then over 1, 2. Up 1, 1, 2. Up 1, 1, 2. Up 1, 1, 2. So it is going at that constant rate. Maybe I'll make some room over here on the left now. So up 1, 2 to the right. So 1/2 is our slope. We know the y-intercept actually. I can see it crosses there at 1. So that's my b value. So I could just go ahead and say 1/2 x plus 1. If we didn't know that, we could take the order pair, maybe the -1, 0, plug it in. Y minus 0 is equal to your slope. X minus the x value, which was -1. It becomes like plus right there. Y minus 0 is just y. Distribute 1/2 x plus 1/2. And I wrote 1. Sorry, that was actually it. My bad. I forgot they're going by 2 0 for a second. There's actually -2 0. So I should have had a 2 there. So when I distribute my 1/2, I actually get 1, which is what I had here. Good. In the domain value, if I think about the x's where that starts, it starts right here and then it went to the right. It was a closed interval. And we're going to the right, so greater than or equal to, and that was right at -2. So there's the equation for that piecewise function. Now let's take a look at the second one. Once again, they're saying g of x, not f of x. I'm gonna switch colors. Some room here. All right, this first one. Now it looks like we're going by 2's again. So it looks like we're going up 2 over 2. So that's the same as up 1 over 1. So 1x or just x. If I were to have continued that line, looks like it would have hit forward. I know that that's going to be my y. Well, it was to the left, so it's going to be a less than. Now it looks like we have an open interval. So if x is less than, and right there where it starts, look on the x-axis was a -2. Then we move to the middle part. The middle part is horizontal, so slope is 0. And the y value is -3. So 0x is the same thing, it's just not writing it, and then -3. And this time x is between two things. It's between -2 and +3. Both closed. Oops, I to erase. And then for the third part, figure out slope. We're going down 2 over 1, down 2 over 1, down 2 over 1. Yeah, so -2 over 1, so that's just -2x. And to figure out the y-intercept, I could just use my point slope formula. when the slope is -2. Maybe leave a little bit more room here. So we have to take an ordered pair, so we could take the ordered pair 3, 6, plug it in. Distribute, add 6, and I get y equals -2x plus 12. So -2x plus 12 goes up here. But that only starts right here at 3 and then moves to the right. It was an open interval, so if x is greater than 3. And there's the piecewise function there. One other special kind of piecewise function in the same unit, there were some that they talk about in the book that we're not going to talk about, but if you look down 8 and 9, we have absolute value. And we did this in the last section, we did parent functions. We should know what they're going to look like, but our book kind of talks about them as a piecewise function because we know they're going to be a V shape. And so they're kind of think of it as you got the left side, you've got the right side, and you got the point that's in the middle of the vertex. You can think of it like 3 parts like that, and that's the way our textbook kind of approaches it in this section. But we also, since we already talked about parent functions, we don't necessarily have to do it that way. But I do want to know where that vertex is going to be. And so the vertex is going to be located at 0, 0, unless we have horizontal or vertical translation. And that happens, if you recall from the transformation section, if there's an H or an K. And in number 8, there is no H or K. So it's actually not shifting left, right, or up or down. So I would try to make a table of values. X, and then instead of Y, we're talking G of X here. But I would want to pick 0, I think. I don't think it moves left and right. Then I'd want to pick numbers to the left and to the right of 0. So we get both sides. And then I would plug them in. So plug in -2. -3 times -2 is positive 6. And the absolute value of that is 6. And plug in -1. -3 times -1 is 3. And the absolute value of that is 3. So -3 times 0 is 0. And the absolute value of that is 0. -3 times 1 is -3. The absolute value of that is 3. -3 times 2 is -6. The absolute value of that is 6. So we get these ordered pairs. Let's go ahead. I'm going to switch colors over here. And let's graph those. Oops, I missed my point there. Let's try it again. 1, 2, 3, 4, 5, 6. And there's our absolute value. Let's do, I circled number 9, but I'm going to actually change that. I want to go and do number 10. So that was number 8 here. But now we're going to look at number 10. So because of the fact that we already did our parent function section, I'm going to approach this problem accordingly. Typically, I would have started at 0 for my vertex, but I see this one shifted and it goes the opposite direction because that's the H. So it's actually went to the left 4. I'm going to go with -4 as my middle number, and then I'm going to surround that. If I go to the left, I've got -6. If I go to the right, I have -3 and -2. And let's plug each of those in now. Hopefully we get something that's symmetric, if I was accurate here. So -6 plus 4 is -2, and the absolute value then is 2. -5 plus 4 is -1, and the absolute value is 1. -4 plus 4 is 0, and the absolute value is 0. -3 plus 4 is 1, the absolute value is 1. -2 plus 4 is 2, absolute value is 2. So I do see some symmetry, which is a good sign. So then I come over here, and let's graph that. And we get our absolute value function. All right, so that covers piecewise functions and special functions. And now we're going to take a look also at section 2.8 because it deals with graphing. Let me pull up the other page. Sorry, not that one. I want to go to this one right here. Okay, so here's some examples that we're going to take a look at for 2.8. So inequalities. We would treat this like it were an equal sign. If it was y equals 4, I would have a horizontal line. The slope is 0. It's a horizontal line of 4. 1, 2, 3, 4. I'm going to have a horizontal line here as well. But now we want to think about the whole line. Is it open or closed? We see that this one should be a closed line, which means we will in fact do a solid line there. In the case that the line's supposed to be open, the whole line we would do is dashed. But I want a solid line here. And then that line actually breaks the whole plane into two parts. We have, in this case, because it's a horizontal line, this section that's above it, and then we have this section that's below it. One of those two half planes contains ordered pairs that satisfy the equation or make sense in the equation, the inequality. Let's pick a point and test it. So I like to test 0, 0. That's an easy point to test. So if I want to come over here and test 0, 0 to see if it works. No 0 is the y value. There's no place to plug in the x. We get 0 is less than or equal to 4. Well, that's a true statement. 0 is less than or equal to 4. So 0, 0 is in fact a solution, and it's below it. So therefore, we understand now that all the points below it must work. And you could test more of them if you don't believe me. But because those work, the ones above the line do not work. The line breaks the graph into apart between the things that work and the things that don't. It's the boundary line. If we look at question, so that was question number 1. Let's go to question number 3. So this one's in standard form. Maybe you remember how to find your x and y intercepts. That would be the easiest way to do this problem. If not, put it in slope-intercept form. X-intercept, plug in 0 for y, you get x is 2. Don't worry about the inequality sign, just use 2. Y-intercept, if 4y is equal to 2, divided by 4, we get 1/2. So on the x-axis, we can go to positive 2. On the y-axis, we go to 1/2. So sneaking in there. And so for slope, looks like I'm going down 1/2 and over 2. So I can continue the down 1/2 over 2, down 1/2 over 2, down 1/2 over 2, down 1/2 over 2, etc. Once again, can be equal to, so it is a solid line. We can graph that line first, and then we have to see where to shade. The points up here or the points down there. So we want to test a point. I like to use 0, 0 as long as it's not on the line. This is pretty close. Maybe it's too close. Maybe I'll test like this point over here. -2, -2. We're going to see if it works. Now, there's no right or wrong number to plug in there, except you can't do a point that's on the line. So when I plug that in, I get -2 for the x, plus 4 times the y, which is another -2, plus equal to 2. So evaluate the left side. 4 times -2 is -8. -2 and -8 makes -10. negative 10 is less than or equal to positive 2. Well, that is a true statement. So I come back over. I happen to get lucky on both of those. I don't necessarily have room. I didn't leave room for number 4. I didn't make a graph because I want to do the absolute value ones down coming up yet. But notice I probably should have done this one because it has an inequality sign. Not equal to sign. So that would be an open interval. So if I did that one, I'll just sketch it real quick. Might not work out very nicely for intercepts, but it would be easy to get y by itself. Maybe we want to put it in slope-intercept form. Subtract the 3x minus the 8L, then I should have made my graph bigger. Here, we'll go by halves. So 1, 2, 3, 4, 5, 6, 7, 8. And then we're going down 3 over 1. Or I can go up 3. I should probably go by halves here as well. Okay, so go up 3 and back 1. Up 3, back 1. I could do that over and over again, but I want to connect the dots. But this time, I want it to be an open interval because it was not equal to in the equation. So open interval as a line is just a dashed line. So connect your points with the dashed line. So now that line is a boundary line. It separates the points that do work and the points that don't. So maybe let's test, I don't know, let's just pick a number over here, like negative 10, 0. That's actually 8. So we're going to try negative 8, 0. We could really plug anything we want in. So plugging 0, negative 8 for the x, plus 0 for the y. We're going to see if it's true. Negative 24 is negative 24 greater than negative 8? Well, no, it's not. It's smaller because it's negative. So therefore, it was over here. It's not a solution. So I don't want to graph that point or anything else on that side of the line. I would have to go to the other side of the line and indicate the solutions are over here. And then the last piece of the graphing inequalities is absolute value. We're merging together two ideas. We've got the absolute value and it's an inequality. So we might want to think of a table of values here. This one got shifted to the left. So instead of starting at 0 in the middle value, it went left 3, so that's a negative 3, and then I can surround that. So I'm picking numbers. That's not real clear. Maybe I'll give myself a little more room for that table. If I go off to the side. So negative 3, and then negative 4, negative 5, negative 2, negative 1. And pretend it's an equal sign when I plug these in. Negative 5 plus 3 is negative 2, and the absolute value of that is 2. Negative 4 plus 3 is negative 1, absolute value is 1. Negative 3 plus 3 is 0, absolute value is 0. Negative 2 plus 3 is 1, absolute value is 1. Negative 1 plus 3 is 2, absolute value is 2. And so, I'm switch colors over here. Whoops. That's not what I meant to do. I guess I won't switch colors. Negative 5, 2. And then negative 4, 1. Negative 3, 0. Negative 2, 1. And negative 1, 2. Now, as I look at this, and I want to think about what kind of line do we want, solid or dashed? Well, it was equal to, so it should be a closed line. So I'll connect the dots. And that broke it into half plane. There's the half plane that's outside underneath, and the half plane that's inside that V. So I just need to test a point in one of the two. So I'm going to test maybe 0, 0. 0 for the Y, 0 for the X. 0 plus 3. So your absolute value is 3. So I get 0 is greater than or equal to 3. Well, that's not a true statement. 0 is not greater than or equal to 3. So 0, 0 is not a solution. Therefore, it shouldn't be shaded. Nothing on that side should be shaded. That's just, okay. So therefore, the points that are inside of the V should have been the ones shaded instead. And then last one, let's take a look at number 7. First of all, I want to get Y by itself. I'm going to add 6. That does not shift it horizontally. It shifts it vertically. So I don't have to worry about that when I make my table of values. So I can still surround 0. So plug those in. Absolute value of -2 is -2. Or sorry, is 2 rather. 2 plus 6 is 8. Absolute value of -1 is 1, plus 6 is 7. Absolute value of 0 is 0, plus 6 is 6. Plug in 1, absolute value of 1 is 1, plus 6 is 7. And absolute value of 2 is 2, plus 6 is 8. This time, notice the sign not equal to, so I need to make my absolute value, my V, a dashed V. And then I need to test a point. I'm going to test the point 0, 0. We'll see if it works. 0 less than absolute value of 0 is 0 plus 6. So I get 0 is less than 6. Well, that's a true statement. So 0, 0 should be shaded. It's on the outside. So therefore, I just come back and shade everything that's outside of my V. All right, so at that point, that covers the notes that I wanted to cover in 2.6 and 2.8, the two graphing sections. Your assignment is kind of twofold. There's a Canvas quiz. It's a 2.6/2.8 Canvas quiz. But then there's also book problems to do. So here, let's see. Here they are. So on page 105, starting on page 105, I want you to do numbers 12, 15, 16, 19, 24, and 28. And then additionally, from the other section, that was 2.6, so this is 2.8, on page, begins on page 119. I want you to do numbers 9, 11, 23, and 24. Typically, we haven't asked you to do book problems, but you can't graph on Canvas really. So I want you to do these hard problems, these hard copy problems. So the Canvas quiz, you'll find like normal. This assignment, the page 105 and 109, it's listed on Canvas as an assignment. It says something to the effect of 2.6 and 2.7, or sorry, 2.6 and 2.8, maybe some practice problems or something. That assignment needs to be submitted on Canvas as well. So you can take a photograph of your graphs once they're done, and then you can upload that. You can use graph paper for this if you want to borrow some graph paper, or you can just sketch your graphs as well. I would accept either one. But that's what I would like you to work on for this section. Sorry I couldn't be in class on Tuesday for periods 5 and 7. Hopefully this video helps.